Hi viewers, this is Sri Ramulu. So today I have come with the most important and the lengthiest topic, that is energy density in electrostatic field. Okay, so energy density in electrostatic field, or it is also called as energy stored in electric field formula. Okay, don't forget, another name is electric energy stored in the form of electric field, energy stored in the form of electric field. All right, now let me start it. Consider three charges q1, q2 and q3 at infinity distance, right? And also consider a surface without charges. Okay, two things we have to consider. One is these three charges not here, they are at infinity distance. And next one is we have take a surface without charges. Okay, three are at infinity and it is a without charges. One surface is considered. Now bring the charge q1 from infinity to okay. Consider three positions on the surface as 1, 2, 3. Okay. Here how many charges we considered? Three charges. Okay. If you want to keep the three charges in at a different places, we have to number them. So first keeping the charge q1 charge place is 1, q2 charge place is 2, q3 charge place is 3. So it is 1, 2, 3. Like this, three different places we have to consider. Now see clearly. Okay, q1 charge place is there, q2 charge place is there. It is q1 charge place, q2 charge, q3 charge. So it is charge surface. But before coming these three charges, it is a charge free or charge free surface or without charge. Okay, so first q1 charge you must keep here only, q2 here only and q3 here only, right? Okay, okay, let me go back. Work done in taking now bring the charge q1 from infinity to position 1. So bring q1 charge from infinity to here. Work done in taking charge q1 to a position 1 is 0. Why it is 0 means actually if there is a one charge and if we bring another charge from certain distance to this charge, then against its repulsion work has to do against repulsion. But here q1 charge I am bringing from infinity to position 1, but in this surface there are no any charges here. So that is why no need to do any work to keep this charge here. So that is why work done is 0. Okay, right? Work done in taking charge q1 to position is 0 because no field exists. So previously no fields are there. Let this work done as w1. Next, bring the charge now bring q2 from infinity distance to a position 2. So bring second to the second position. Now work has to do against repulsion. Why? Because already we kept charge 1 here. If you bring the second charge may repel with because of this first charge. So against repulsion if you bring it, then we must do work. Without doing work this charge cannot come this side, it cannot come to the place second place, it cannot occupy the second place. Okay, so that is why against this repulsion we have to bring this charge. So we must do the work. Therefore, work done in this process W2 is equals to, let is a W2. W2 is equals to, you know the work is equals to charge into potential. This is a formula. Work is equals to charge into potential formula. And why it is written as a V21. So V21 indicates here, it is written, see, that is also explained here, where V21 is potential at the location of Q2 due to Q1, at the location of 2 due to 1, right? At the location of charge 2, so 2 is written first, due to Q1, so 1 is written later. Okay, so I think you have understood. Similarly, bring Q3 charge from infinity to position 3, 3, right? So third charge we have to bring from where to where? From infinity to this position. Already there are the two charges, don't forget it. So while bringing the third charges, we must do work. Okay, keep it in mind. Okay, similarly bring Q3 charge from infinity to position 3. The work done against work done is given by W3. W3 is written as what? So work is charge into potential, but here work is Q3 V31 plus Q3 V32. Why it is Q3 V31 V32? Here Q3 is charge bringing, right, charge into potential. Potential is, this potential is third position potential because of first charge. Okay, so due to the first charge, certain potential will create on the second charge. It is because of second charge. Okay, so third charge can get affected with the first charge with the second charge, so that is the meaning. So both charges can affect the third charge, right? So because of both charges are written here, potentials, where V31 and V32 are the potential at position 3 due to charges Q1 and Q2. So that is why what is written here, see here what is written, sorry for this disturbance. That is why, right? So here V31 and V32 are the potentials at position third, at third position, due to charge Q1 and charge Q2. So that is why here 1 and 2 is written. Okay, next, now total charge. Total charge is what? Total work done is total work done is what? We is equals to, E indicates electric field, is equals W1 plus W2 plus W3. W1 answer is 0, W2 answer is this, W3 answer is this one, see above. Right, so W1 already 0, W2 is this one, W3 is this, W1 0, W2, W3, right? I think you have understood it clearly. Okay, and from this we can write like this by removing the 0. Let it is equation 1. Next, let us consider that three charges are brought in the reverse order. That is, charge Q3 is taken first, then charge Q2, and finally Q1 to infinity. So what we have to do here, previously what we have done, first we brought from infinity to this position charge 1, next charge 2, next charge 3. Now what we have to do, we have to do the reverse process. In reverse process, which charge we have to bring first? Bring the charge Q3 first, next Q2, next Q1 to the where? To the infinity distance. Okay, it is reverse process. In the reverse process, see here. Okay, so in the reverse process, what we get? In the reverse process we get this one. Okay, in the reverse process, in forward process we got like this. In the reverse process, what we get? First we have to bring the Q3 charge to the infinity. So at the infinity, suppose at infinity place there are no charges. When you are bringing the Q3 charge at the infinity, the value of work is 0. Let it work is 0, let it is W1 and 0. Okay, so keep it so let Q3 is kept at infinity. Next, bring the Q2 charge. from the position 2. Q2 charge bring Q2 from position 2 to infinity. At infinity already what is there? Third charge is there. So we must do work. Let that work is W. W2 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 is what? Charge into potential. Charge is with charge Q2 into potential is 2 3. Why? It is a it is V means 2 3 means second charge. It is because of the second charge because of third charge. That is a meaning. Okay. So for V2C it is W1 0 value, W3 is like this. Okay. So at infinity how many charges are there? Q2 and Q3 is there. And now bring charge Q1 to the infinity distance. Okay, at infinity. So already how many charges are there? Two charges are there. If you bring this, we must do the work against repulsion. Then let work is W3. W3 is what? Q1. Potential 1 because of 2 plus Q2. Potential Q1 1 potential 1 because of third charge. So see, in reverse process it is. This is in forward process. In reverse process also we got the W value 0 1 and the remaining value is like this. Okay. Now let it is make write it is like this second one in this manner and make it is equation 2. Add the equation 1 and 2. After adding, W plus W becomes 2W, and this side these two we add. So this is written where? Here, right? Check it now. And it is written where? Here. Added, both are added. After addition, now take charge Q1 common. Where here where we have the Q1? Here and here. So Q1. So if you take if you take common Q1, then we get like this. If you take Q2, where we have Q2? Here and here. So then it is a Q2. Bring common outside Q3. Q3 here, Q3 here, Q3 into this. Okay. Now write a single terms. Two voltages are there. Instead of two voltages, write one voltage. Here common term is what's common number is for this 1 1. Let it is a potential 1. Here 2 2. Let the potential is 2. 3 3. Potential is 3. Okay. So commonly we have written like this. And for what we have written it is mentioned here. For what things we have written. Okay. And bring this to this side also, then we get like this. Finally W. Okay. It is for only 3 particles we consider, 3 charges. Let there are the n number of charges. What we write, we can write like this for n number of charges. I value or W equals to 1 by 2. I value running from 1 to n Q I V I. If you write first one, then Q1 V1 plus summation means plus. Next write 2 Q2 V2 plus write 3 Q3 V3 plus so on up to n. So that is why we can get this one only. So it is a short form. It is short form of this for n particles or n charges. Okay, next. Okay. To get general expression for energy summation, summation is replaced by integration. In the above equation C, summation is there, replace it with integration. Okay, integration is written. And Q in the place of Q, what we have to write? Rho dV, rho into volume, smaller volume it is, rho dV. Okay. Okay, in the place of what we have written, in the place of Q, only in the place of Q write this one. And in the place of VI, V write V. In the place of V write V only. And in the place of Q, rho dV. Okay, substitute these values here, then what you get? You get this is, isn't it? according to Gauss law. So differential form of Gauss law is there. Please watch the video. Already I uploaded. Differential form of Gauss law is del dot D is equals to rho. So that means in the place of rho we can substitute this one. Yes. So when A dot B into V is there, so then the formula, there is a formula, what you know, uh, so there is a vector form according to vector formula. So it is a vector formula, del dot Vd is equals to, first write V outside and del dot D. Next write D outside by doing plus, by write D outside del V. Okay, once again, first when you have in this form, write V outside and write del dot D. Next write D outside and write del into V. Okay, now what we need, we need del dot into V, we need. So where it is, here it is. So bring this side, it is already plus is there. When you bring it is this side, it become minus, right? It is minus. So in the place of this we can substitute this one. So substitute that is here, then it is this one. Now multiply 1 by 2 integration and dv inside, write separately. So it is on separate form, it is separate form by minus. Okay, let it is equation 5. Now if you observe here, according to Gauss theorem of divergence, so for what things we are going to apply the Gauss theorem, you know, for this only. Okay, so Gauss theorem is what, you know, Gauss theorem is integral a dot ds is equals to triple integral del dot a into dv present. Okay, so for this, once outside is taken and see written in the same form what I explained. So it is, let it is a one single term as vector way a. So vector a is equals to del dot vector a. So like this we have to write. It is what Gauss theorem of divergence. So double integral, ds means double integral is converted into triple integrals, and substitute this value. So in the place of this, substitute this one, then we get this one. But so this value is 0, but surface integral over a closed surface is always 0. So this time is 0. Substitute 0 value, then what we get? Only we get this one with minus, right? So minus with minus, only this term we get. So it is this, and write minus inside like this. Already we know the formula of this, right? Already we know. So please watch the videos, all the videos are there. This one, okay. So in the place of this, what e is written, e, and d's are there. So d is equals to epsilon naught into e. So epsilon naught into e into e square only. Okay, now and take these quantities outside, half epsilon naught e square, and what you get, you know, you can get is total volume. You can get dv is a small volume, by integrating it total volume. So total volume is this, bring this total value in this side, work by total volume. Work by total volume is called energy density. So energy density is half epsilon naught e square. This is energy density or energy stored in electric field formula. So U is equals to 1 by 2 epsilon naught e square. Don't forget, it is very important. So please watch